Hi, let's solve today's question, that is evaluate reverse Polish notation. So in this question, we are basically given an array of strings called tokens, which basically represents an arithmetic expression in a reverse Polish notation. And we have to evaluate this expression and return an integer that represents the value of the expression. So here we can see we're given a array of strings, right? So this is the strings and this is the array of these strings, and these basically represent an arithmetic operation. Now what is reverse Polish notation? That you can click on this link and get to know. So it is nothing but basically represents an arithmetic expression in which the operators are just after the operands. Okay, so it's like a postfix kind of an expression. So we are given these tokens and we have to evaluate what value we will get out of these arithmetic expressions. Now here are some things written for this particular problem. So first thing is, what are the operators that we will be using? We will be using plus, minus, multiplication and divide operators. Then each operand is integer or another expression. Okay, then the division between two integer always truncates towards 0. There will not be any division by 0, and the input represents a valid arithmetic expression in reverse Polish notation. Now whatever input is given to us is valid, right? There will not be anything as such where we cannot reach to a solution, right? So each string leads us, each array of string leads us to a solution, right? It's a valid arithmetic expression. Then the answer and the intermediate. Okay, so that is basically everything can be represented in integer. Now let us understand what the given question is and how we will be solving this question, right? So begin something like this. So let's come to the whiteboard. Okay, so here is the whiteboard. Now what are we given? We're given this array of strings, right? And what are we told? We are told to evaluate it, right? So we can say that we are something given something like this, 2 1, right? These are integers. Then we have a plus operator, then we have 3, and then we have multiplication. I have to calculate what is the value that I'm going to get out of this. Now how, first thing is, how can I calculate this, right? Because this is given in reverse Polish notation. So what happens in that is, we basically have the operators after the operand. So here we can see plus is an operator and operands are 1 and 2 for it, right? So 2 and 1 and then plus. So this basically means 2 plus 1, right? And then we have a 3. So first we have to calculate what this leads to. This is 3, right? Then we have calculated. For this, the story is done. Now I have to come here. So this is 3, right? This became 3 and we have this 3. Then I again come to this operator, which is a multiplication operator. So 3, 3 and this multiplication basically means that we have to multiply them, and what I will get a 9 here, right? So I hope you are getting what this is and how we are going to evaluate, right? So let's take this string. Okay, let me clear the board a bit. All right, so we are given this, right? So how can I write it? So first I'll just take the integers from here, 9, 3, then we have this plus operator, then we have a minus 11, then we have this multiplication, then divide, then another multiplication, a 17, then a plus 5 and plus. All right, so this is the given string. Now I have to calculate the value that it is going to yield, right? How am I going to go about it? So I'll first start with, let's say I start with this operator, that is the plus operator, and I have to take two operands, right? So two operands are this, right? So by now it must be clear to you that what is the number of operands that we take with each operator, right? So here we have plus, minus, divide and multiplication. So all of these operators, right, we are given only these four operators will be used throughout the question. So these four operators always use two operands, right? And another thing about them is that the order for plus and minus doesn't matter, right? I can write 2 plus 3, it is going to give me 5, or 3 plus 2, it is going to give me 5. But if I talk about minus, then 2 minus 3 is minus 1 and 3 minus 2 is plus 1, right? So this is the difference between plus and multiplication and minus and divide, right? So in plus and multiplication, the order of operands doesn't matter, but in minus and divide, it does matter, right? So we have to take care of this as well, right? So here in this question, basically whatever operand is written first, let's say 2 is written here, 3 is written, and plus is written here. So we will write it like 2 plus 3, right? So let's say this was not plus, instead was divide. So we have to do 2 divided by 3. So that's how we know, okay? All right, so I hope these two things are clear. The operators, the number of operands each of these operators take, and the sequence of operands when we consider these operators. All right, now let's begin with this plus symbol. So I can see that this is going to yield a easy expression. I know that I have two numbers and I have to add them because plus is written after them. So this will lead to an expression, right? So this will basically become 10, 6, and this is nothing but 12, right? And we have minus 11 multiplication, and just copy the whole string. Okay, now I can see that this is a multiplication operator, so I'm going to take it. So I'll simply do a multiplication here and it will give me minus 32, right? And then we have a 6, a 10, and this oblique, a multiplication, a 17, a plus, a 5, and plus, right? Then we have to take these two, right? And we have to calculate. So here the order is important, right? Until now we were using plus or multiplication, but here the order is important. We have to divide 6 by minus 132 and not minus 132 by 6, right? So here, after dividing, because we are considering integers, we are not considering any decimal calculations here, so it is going to give me 0. So I have 10, 0, a multiplication, a 17, plus 5, and a plus operator. Then I have to calculate this expression, will become 0, 17 plus 5 and plus. Now I have these two operands, right? So which will give me 0 plus 17 because we have a plus operator and these two are present before plus. So we'll add these. So we'll get something like 17, right? 0 plus 17 is 17, and a 5 and a plus. Now we can say that the final result is going to be 22. So 22 here is going to be my answer. So I hope you are now able to get how we are going to evaluate the arithmetic expression. So after doing this, or I suggest you to write a string of your own and try to calculate that arithmetic operation, or you can find that on internet as well. After doing it several times, you'll notice one thing, right? What we have to basically do is, see, first of all, there is a distinction between numbers and operators, right? So these four we have to treat differently than the numbers. So first thing is that. So first thing is clear that there are two different things here. There are two distinctions, that is either whichever token I am standing at, it will be a number or it will be an operator, right? So what if it is a number, right? So here we can see that the last two operands, we must know them, right? Basically all the operands that we get from the starting, we must be knowing the value of them. So whenever we arrive at an operator, we can calculate what the last two operands will give us, right? So that is the second thing that I can notice, right? So let me clear the board again and let's try to understand what is happening in the question and what are these observations that we have made. Okay, so let's write these observations. Observation 1, distinction between operators and operands, right? So operands are nothing but numbers on which we have to do a particular operation, and operators are nothing but plus, minus, divide, and multiplication. What is the second observation? What can we observe secondly here? That we have to store these numbers somewhere. Only then we will be able to do these calculations, right? So the last two operands we have to get each time, and we have to also put the result of that operation, right, inside of some structure. So we are going, let's say we take an array here. All right, okay, that is also fine. Then observation 3, the way that we are going to use this particular structure is that we want to get the last two operands from the structure, right, wherever we are going to store. So instead of array, would it be good to say that we can use stack here? Because stack is what? LeetCode order. What goes first comes out last, or what goes last comes out first, right? So here, because we want the last two numbers or operands That is why we are going to use a stack here, right? This is the observation 3 and this is the main observation of the question, right? That is what you have to observe here. Okay, then sorry, observation 4. What will be the observation 4? The observation 4 is that after you understand how to evaluate this reverse polish notation, you will find out that you will keep taking numbers and numbers up till this point, right? You will store them inside of your structure, that is a stack. After that, the very first operator that you encounter, you have to perform some calculation, right? So the thing here is to notice is that if you are going from left to right, the very first operator you get, you have to calculate it, right? And it is true, right? You can again try to write this down, or you can skip the video towards some minutes back, and you will find out what we were basically doing was the very first operator we get and we take the result, right, of the last two operands and perform that operation on those two operands, right? So this is essentially what we have to do. So we have to iterate in this string of array of strings, right? So we will iterate from left to right. Although the question might be reverse polish notation, but it is not necessary to operate from here. And the reason is very simple. If you start operating from here, how are you going to know what are the two operands you are going to use? But when you operate from the from left to right manner, you will be able to get your operands very easily, and by keeping doing these operations, you will be able to go to the last operator and perform operation for this, right? So that is why we don't start from the right to left order, but we start from left to right order. So this is the observation 4. So these 4 observations are enough for us to solve this question. Now let us see how we are going to, let's put them all together and understand the approach of the question. So the thing that I said is the main observation is the stack, right? Identifying that stack is the data structure that we are going to use here. And the reason is because we have to get the last two operators. So what we will do is we will be iterating this particular array, right? So again, observation one comes into play, that the distinction between operators and operand. If we get to an operand, right, we will be storing it inside of our structure, right? So here I'll just write store number somewhere. All right. Okay, so then we iterate from here. We start from 10. Let me change the color. So let's select red. Okay. So we are iterating from here, right? I hope that's visible. So we come to 10. So we will make our stack, and right now stack was empty and we put 10 here. Then we see the next item inside of this array is 6. That is a number. So put here. Then we see there is a 9. Put inside of the stack. Then go ahead and we come to 3 and it is 3. It is a number. Put it inside of the stack. Now, as soon as we reach an operator, we have to perform an operation, right? So plus we will not be storing inside the stack because we don't need it, right? On a later stage. Why would we require operator? Whenever we get an operator, we have our operands and we have to perform the operation. So now is the main logic. As soon as I get this plus, right? So as I know the stack is LIFO order, I can simply get the top element of the stack, that is 3 and 9, right? So here, as I mentioned, the order of operands is also necessary in some cases, that is minus and divide, subtracting and dividing. But we will consider in all the cases, right? Otherwise, we will have to check if this is plus or multiplication, then we will preserve the order, otherwise we will not, right? So in case in plus and multiplication also we can preserve the order, right? So I have to take the top element and I will say that this is operand 2, okay? And then it will be outside of the stack and operand 2 will become 3, and then we will take the next top element, that is now what is the top element of the stack, which is 9, and it will become operand 1. So whatever operation I perform, I will do operand 1, and here the operation is plus, so I can simply write like this. So even if this was a minus sign, we would have preserved the order. So that is what we are going to do. So this is the first top element that we get out of the stack is going to be operand 2, and the next popped element would be our operand 1, and this will be the order. So now we will calculate what is going to yield. It will give us 12, right? So here 9 and 3 are removed, but we have to put this result back here, because after evaluating this expression, right, this whole expression, we get a value which is 12, and we have to use this value for later evaluation, right? So we have to put 12 inside the stack. Then we will keep iterating, we come to 11. Okay, this is a number, so simply put it inside the stack. All right, then we come to this multiplication operator. Now I have come to an operator, so I have to handle it differently, right? This is not a number, this is operator. So I have to take again the top two elements. So the top two, this is operand 2, this is operand 1, right? So we have to perform 12 into minus 11, which will give me minus 132. So I will pop these two elements out and push this minus 132 inside of my stack, right? So let me create another stack here and write clearly what the stack is now. This is 10, this is 6. And we have minus 132 inside of the stack. All right, so we have up to here, we have calculated the expression. Then we will come to this. So again, a operator, right? Handle it differently. This is not a number. Take out the two operands from the stack, top two operands, and perform this operation on them. So here now you can see why I am saying you have to take operator 2 and operand 1 and operand 2 like this, right? So because we have to preserve the order in case of division and subtraction, right? So here we have to calculate 6 divided by minus 132 and not vice versa. So this will give me 0. So we had popped these elements out and performed this operation and put 0 inside of the stack. So okay, up to here we have done. And then again is an operator, right? So now we have 0 and 10 inside of the stack. So we have to perform 10 into 0, right? So we will pop 10 and 0 out and put 0 inside of the stack after performing this particular multiplication operation on the last two operands. Then we come to 17. This is a number, all right, so it's easy, push it inside of the stack. Then we arrive at an operator which is plus. So we have to add the last two operands, that is 17 and 0. So push its value, right? And we will be popping these elements out. So we have 17 inside of the stack. Then is again a number. Then we reach the last token of this particular array, and here we can see that this is an operator. So handle it differently. Take out the last two operands and perform the calculation. So we will get 22 in this case, and we will put it inside of the stack. Now I can see after the whole iteration, because this every expression that will be given to us in the input is a valid expression, right? So I can safely say by the end of the iteration, whatever is my stack's top element, that will be my answer, and the stack is going to contain only one element in the last. That will be our answer. Okay, so this is basically the flow of the question, approach of the question. Now one question you might be having is that here we are giving strings, right? We don't know this is a number, this is rather a string, right? So this is a string. How are we going to get that okay, this is an operator or this is a number? So we can simply check for plus, minus, divide and multiplication explicitly, right? So we can simply say if tokens of I, right? So the ith string in this array, if this is equal to plus, right? Similarly minus or a divide sign, which is like this. Let's say this is multiplication, a divide, right? So we only have these 4 cases, so we can use these, right? You can simply check this explicitly, and I know there are only 2 distinctions here, that is either the operator is present. So token of I is either a operator or a operand. So if it is an operator, then do this, right? Go into the stack, check what are the last 2 elements are and perform the operation. Otherwise we know simply put it inside of the stack. And I have 10, right? So this is a string right now. So I can use, in C++ there is a function called stoi, which we can use to convert the given string into an integer. So we will simply push this inside of the stack, okay? So this is how we are going to create distinction. So for operators, we will explicitly handle them. And if they are not operator, I'm sure that they are numbers and they are my operands and I have to push it inside the stack. And how are we going to push it inside the stack? By converting them as an integer. Okay, now I hope the approach is clear to you. Now let us go ahead and code this out. All right, so here first we will be creating our stack, right? And stack of integer is what we are going to create, so let's call it st. Now quickly I'll just take the size of this tokens array here, tokens dot size. All right, now I will go and iterate. So I know in a single iteration I can perform everything, right? So I'll say for int I is equal to 0, I less than n, and I plus plus. Now there will be two distinction. Either the tokens of I is a number or an operator. So for operator, I can handle that explicitly. So I will check if tokens of I is equal plus, or if it's equal minus, or if it is equal a multiplication, or tokens of I is equal division, right? So I have handled all the operators. There are only 4 operators, right? Now we will write the logic for what if the tokens of I is an operator. But before that, let me quickly just write the condition for if it is going to be a number. So I'll say st dot push. I know if it is a number, I have to simply put it inside the stack. So I'll say st dot push, and first I have to convert it into an integer because tokens of I is a string, right? So we'll use this stoi function and we'll convert it into a number or an integer. Okay, so we can simply say tokens of I here. So all right, number is handled, operator is handled. Now let us go ahead and write the logic. What if it is an operator? So what if it is an operator? We know that we have to take the last 2 elements of the stack and perform this operation. So as I said, the topmost element will be my operand 2, right? That is the order that we are using for reverse Polish notation, right? So I'll first take operand 2 from the top of the stack. Okay, so I've got my operand 2 and I can simply remove this operand from the stack. Then we will take operand 1 from the stack, which will be the top element of the stack now, and then I will remove this element as well because I have to use these two, right, to perform calculation. Now I will take a rest variable. Now in this rest variable I'm going to calculate whatever value I'm going to get after performing that particular operation. Now how am I going to know whether I have to do plus or minus or multiplication or slash? So I cannot use directly this tokens of I, because it's a string. So rather I can add another condition to calculate res, that if tokens of I, let's say it's equal plus, right? So please put inside of res operand 1 plus operand 2, its value, right? And we'll just do this 4 times because we have 4 different operators and we will do this for each operator, right? And we will simply divide. If this is a minus, minus we have already taken, multiplication it is, so we'll multiply these, right? So this we have done. Now the next thing is, after calculating this resultant value of this operation, we have to put it inside of the stack for further evaluation. So I can say st.push this result. All right, so now this is the whole logic. If we come across any operator, this is what we have to do, right? Now we know after performing this iteration, right, because the expression is valid, we will be having an answer by the end, and that will be the stack's top element. The stack is going to contain only one element, that is the answer, right? So I can simply return the top element of the stack, right? Okay, now let us quickly go and check if this works. Okay, so this is accepted, right? So this is basically how we have to solve this question, right? Now let us discuss about the time and space complexity. So the time complexity, you can simply say we are only iterating once throughout the whole string. So it is going to be big O of n only. And if we talk about space complexity, the space is because of this stack, and at most n number of elements can be in the stack, and it will definitely be lesser than that because there will be some operators and it is a valid expression. So definitely numbers, um so there will be operators and numbers, so whatever value is, so it's kind of n minus x something, we don't know the number of operators that are going to be in tokens array, but we can surely say that the upper bound will be big O of n only. So time and space complexity were both big O of n in this case.